We've been talking a lot about slope in this unit so far, and we've talked about slope in lots of different ways. Slope from a line, slope from 2 points, slope from point slope form, slope intercept form, standard form. These are all things you should be familiar with in this unit right now. So make sure you're going back and practicing those things and doing those reviews. Look at the I can statements, watch the videos, look at the practice activities in previous days' lessons. Today, we're going to take our graphing skills we already have, and we're going to take it up a notch and do it one step further, and we're going to be graphing inequalities. So a quick reminder that when I'm graphing inequalities, that's when I'm going to use the symbols like less than or greater than, less than or equal to, greater than or equal to. Remember, if it's less than or greater than, it's going to be an open circle. If it's greater than or equal to, less than or equal to, greater or equal to, this is a closed circle. So before we did things like y is less than 3, and we graphed that on a number line, and we said, okay, I have 3, and I know the number before and the number after it. This is going to be an open circle going to the left. That's what we graphed. So that's what we did before. So we're going to take it up now, and we're going to graph not just single numbers like this, but we're going to graph equations. Graph equations. It's going to look like this. Let's remember, if I have something like, let's say, 3x minus 2, y equals 3x minus 2. That is a linear equation, not an inequality. It's a linear equation. It has an equal sign, so it's an equation. This is in slope-intercept form, and we've already done this in this unit. So slope-intercept form means I know the slope, and I know the y-intercept. Those are the two things I get from slope-intercept form. I know the slope and the y-intercept. The slope is the constant. It's -2. And the y-intercept is the coefficient. I'm sorry, the y-intercept is -2, and the slope is a coefficient. Put those backwards, right? So the slope is, got backwards. Our brain is tired today. There we go. The slope is 3, and the y-intercept is the constant, which is -2. Sorry about that. My brain gets things mixed up sometimes too. So make sure you're taking good notes, and we'll make sure we get your notes correct so you can look back at those. So this is the slope, and this is the y-intercept from slope-intercept form. So if I have those two things, I can graph them. First, I graph the y-intercept, which is -2. And then I'm going to use my slope of 3, and I'm going to go up 3 over 1, up 3 over 1. And from that, I can draw a line. So this is what I did before. Okay? Now we're going to change it just a little bit. So let me erase that. And let's do the same thing, but this time let's make it less than 3x minus 2. So instead of being equal to, we're now going to make it an inequality. So how does that change how we graph it? It doesn't really change it a whole lot. There's just two little things that we have to think about with inequalities or it might change this. So we're still going to have our slope of 3. We're still going to have our y-intercept of -2. So we're still going to graph that y-intercept. We're still going to follow that same slope, and we're going to get those points that are going to go like this. But now I have to pay up 3 over 1. There we go. Now I have to pay attention before I draw that line. I have to stop and think. Is it going to be solid or dashed? Solid or dashed. Now this is different than open or closed. It's kind of similar than open and closed, only now we're going to call it solid or dashed. Because the types of lines I can have on graphs is I can have a dashed line like this. So a dashed line means not equal to. So it's less than or greater than. So if I see one of those two symbols, less than or greater than, I'm going to use a dashed line. If I have a solid line, that's less than or equal to, or greater than or equal to. So now I have to think about what type of line will I graph. So in this case, it's less than or greater than, no equal sign, dashed. If there's an equal sign, you're going to draw a solid line. So in this case, what I have is I have a less than. So this is going to stay a dashed line. I'll still add my arrows to both sides. So that's the first thing, dotted or dashed line. The second thing you have to think about is, do I shade above? Shade? Do I shade above or do I shade below? Which way do I shade? Because I'm going to color in part of my graph. I'm either going to color in the part that's above the line or I'm going to color in the part that's below the line. And how do I know which one is which? Well, imagine, if you would, like a little ant. He's kind of walking right here. And he's walking on this line and he's headed up this wall right here. So if he's walking up this wall, the sky is above his head and the ground is below his feet. So you can kind of orient yourself with which is above and which is below. So in this particular case, on a positive slope, this is above and this is below on the slide. So if I'm doing less than the below one right here, the below one, that's going to be for less than or equal to. If I have either one of those, I'm going to shade below. So in this case, I do have less than, that's my symbol, so I am going to shade below. So I'm going to very neatly and very carefully, as best as I can, it's hard to do on my screen, but yours will be easier. I'm going to color that in. So I'm going to shade below. If it had been greater than or equal to, I would have shaded above the ant's head. Okay? So we're going to do exactly like we did before. We find the slope, we find the y-intercept, we graph the line, just like we did in slope-intercept form. Only now we need to decide solid or dashed, which one are we going to draw. If it is an equal, there's an equal sign, there's that little line, it's a solid line. You see the line, you draw a line. If you don't see the line underneath of it, like this one right here, there is no line. If there is no line, it's dashed. You just draw a little dashed line all across, all right? Second thing, above or below. If it's less than, it's below. If it's greater than, it's above. All right, let's look at a couple more examples. Let's make sure in your notes you have when do you do dashed and when do you do solid. So remember you have it's less than or greater than is a dashed line. Less than or equal to, greater than or equal to is a solid line. Less than or equal to, we're going to shade below. Greater than or greater than or equal to, we're going to shade above. And I would write the words shade above, shade below, dotted dash. You'd write those words right in your notes. I'm not writing them on the screen, but you should write them on your paper. All right, so what if I have something like y is greater than or equal to 4x minus 5? What is my slope and what is my y-intercept? My slope is 4, the coefficient, and my y-intercept is -5, the constant, -5. So I graph the -5, and I do my slope of 4, 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 1. So this gives me my line. Now, before I draw it, stop and think. Do I have a line? I do. There's an equal sign. If I see the equal sign, if I see that line, then I draw a line. Don't automatically draw a solid line because it might be a dashed line. It might, so be careful. If there was no line right here, it would have been a dashed line instead. Second thing, shade above or shade below. Shade above. If it's greater than, what do your notes say to do? Greater than, we shade above. So imagine this little ants walking here. Where's the sky? The sky is up here, so I'm going to shade all of this. So I would color in that part of the graph. Just carefully. When you have a pencil, it's a lot easier to shade it all in. Without a pencil, it's a lot harder to do it. But take your time and try and do it as neatly as you can and shade that all in. You can sometimes take like the highlighter and kind of highlight it all in. That works as well too. Possibilities. All right. Let's look at another one. What if I have something like, let's do 2y is less than or equal to 4x minus 10. What if I have something like that? Is that in slope-intercept form? No. And if it's not in slope-intercept form, you need to put it in slope-intercept form. So what's keeping the y from being by itself? Back to our first trimester skills. How do you isolate that variable? What is the inverse operation? We're going to divide both sides by 2, and we would get y equals. We rewrite this as the two fractions. If we rewrite that as two fractions, we get with 2x minus 5. Now it's slope-intercept form. Oh, sorry. I wrote an equal sign. And we have a visitor. Hello, Percy. Everybody say hi, Percy. Hi, Percy. Hi, everybody. Your guest teacher for the day. All right, so it's easy to just write that it's easier to write that equal sign. We want to do less than or equal to. Here, you're going to need to get down. You're going to be too much of a distraction. All right, bye, Percy. See you later. It'll be too much of a distraction. So it's less than or equal to. So I have my slope. My slope is 2. I have my y-intercept. It's -5. So I plot those points, -5, and then my slope is 2. So I can graph that line. Now, is it solid or dashed? There's a line. If there's a line, I draw a line, but you have to look first because it might be dashed. And then I shade above or below. I'm going to shade below. I'm going to shade below. So if I have that little ant walking here, where is the ground? The ground is below his feet. It's going to go like this. All right. If I have a line as I'm graphing, if I'm graphing it and my line ends up being, let's say this way, it's a negative slope like this way, then the ant walks on this side. The ant walks there. So this would be above, and this would be below. Sorry, I should draw this way. That would be above on that side and below on the other side. So I'd make this little picture in your notes. If it's a negative slope, you have above and below. My cat is nothing if not persistent. You have to get down. You can't be up here right now. Kind of like my children sometimes, which being persistent is a good thing in life right now. All right, a couple more examples. What if I have something like, let's do one more like this. 4y is less than 12x minus 4. Okay, do one more like this. Okay, where you have to solve for y. So if I say divide by 4 and divide by 4, we get y equals 3x minus 1. So we have negative 1. We go up 3 over 1, up 3 over 1. We draw our line. This would be a dashed line because there is no line right here. There is no line, so it's a dashed line. And this one, it's less than. If it's less than, then we shade below. Be down here below. So that would look like that. Neatly done. It's hard to do neatly with my stylus. Okay. Another example. What if I have something a little bit trickier? What if I have x is less than negative 4? Now we're not drawing this on a number line. We're doing this as a graph on a coordinate plane. So it has lots and lots of points that are that possibility. If we have x is less than 4, then I know it's going to need to be a dashed line because I see this. There's no line, so it's a dashed line, and I'm going to have to shade below. So I know those two things just going in. The question is, where is x equal negative 4? And x equals negative 4 right here. And all the way up here, and all the way down here. If you ever have x equals, as soon as you see that x on the left by itself, you know it's going to be an undefined line. It's going to be a vertical line every single time. So just watch out for those when those happen. So the question is, which is above and which is below? So, well, what numbers are less than negative 4? Numbers that are less than negative 4 are negative 6, negative 8, negative 10. These are the numbers that are less than negative 4. So this is the below side. That's the below side. And this would be the above side. So I'd also make that little graph in your notes so you can look back at that and remember that this is the below side. The numbers get smaller, and this is the above side that goes there. All right, what if we flip it? Or if we flip it and we have something like y is greater than or equal to 3? What if we do that? That's going to be a horizontal line. The slope is 0, right? The slope is 0. So where's y equal to 3? Right here. And that would be a solid line because I see the equal sign. So it would be a solid line, and we're going to shade above. So above is here, below is here. So this one we would shade this way. So watch out for those horizontal and vertical lines when those come up from there. All right, what questions do we have? Are we stuck anywhere? Can you flip through and take a look and see? Oh, let's do one like this. What if I have something like last one? As I flip through and look at what you need to do for practice today. Can you solve for y? Solving for y is super important. Let's do, no, let's make it another one. Let's do 12x plus 3y equals 21. Okay, solve for y. Solve for y means move the constant, both of those, leaves us with 3y equals, remember to leave this clunky and chunky, do not combine, just leave that negative 12x plus 21. I'll have to put a video for solve for y on this page. So if you don't know how to solve for y, you need to make sure you go back to that because it's something we're not taking time to teach right now. Did it a lot last trimester. All right, then we're going to divide both, move the coefficient, divide both sides by 3. We get y equals, rewrite this as the two fractions, negative 12x over 3 and 21 over 3, two different fractions. We get negative 4x plus 7. Okay, now I can graph it. Sorry, I meant to make it a less than. Inequality. We're so used to write those equal signs that we forget. It's inequalities for this lesson today. So we got to change that to an inequality, not an equation. So let's make it a less than sign. Make it easier. All right. So now I have my slope is negative 4 and my y-intercept is 7. So there's my y-intercept of 7 and my slope goes down 4 over 1, down 4 over 1. And I have my line and it's going to be dashed. So dash that way. And our little ant is walking right here. So this is above and this is below. If it's less than, which one do we color? If it's less than, we color below. So all of these are possible solutions to this equation or inequality. So if I picked any point over here, if I picked, like, say, this point right here, that point is negative 6, 2. If I took and I put that point in, if I put negative 6 for x and I put 2 in for y, if I put negative 6 in for x and I put 2 in for y, if I substituted those, then whatever I get for this would be less than 21. That point would work. It would be a solution to that inequality. That's what these are all about, is every single point on this side is a solution. If I take those values and plug them in back to our functions unit, it will work. Everything on this side, not a solution. Is not a solution to these inequalities at all. So if I took this point, if I took 8, 1, and I plugged, if that was my coordinate point, if I took 8 and plugged it in for x and 1 and plugged it in for y, and I did this math, it would not be less than 21. It would not work. It is not a solution. And that's the whole point of the dash and the dotted lines. So when I have a dashed line like this, that means that any numbers that are right on that line, so like this point right here, is not a solution. It will not work. If that's a solid line, if that was a solid line through there, then any point that's on that line is a solution. It will work. If I take that coordinate pair and I plug those in using function notation, then it will work. It is a solution. All right? Double check your notes. Watch this video maybe twice if you need to. Definitely a little bit of a trickier skill. What we were doing before, getting it to slope-intercept form, finding the slope-intercept, or the slope and the y-intercept, being able to graph the line. Our guest visitor's back again. Percy, you're not helpful. You're not helpful. Pets. They are fun, no doubt, I'm sure. So anyway, let me know what questions you have. Send me a message or ask me with me online, and we will get this taken care of. You can do it. Come on, guys, dig in. We'll see you again soon.